All right, good morning. Hope everybody had a good weekend. And if we look into once again what we have with polynomials and inequalities, and we have on page 332, again, we are resuming working with polynomial functions, and then we'll make a bit of a segue over to rational inequalities. And also in the mix, we'll have a little bit of a tie-in with the previous topics we have had with zeros and multiplicities, as well as in behaviors of the various graphs of functions. And for what we have on page 332, and we have, in the case of number 17, we have a function f of x set equal to negative x squared, okay, plus x plus 12. And we have a 5-part problem situation with this particular function. And first of all, okay, so if we have that negative x squared plus x plus 12 is equal to 0. Okay, and this is one equation whereupon the trinomial can be factored. Okay, and so if I just rewrite what I have here, and it will not change the zeros of this particular expression. Okay, so if I were to multiply the equation by -1, okay, so as to make the first term to be, instead of negative x squared, to make it a positive x squared. Okay, so if I multiply this equation by -1, okay, so we're going to have x squared minus x minus 12 is equal to 0. Okay, so just looking at applying the factoring. So we have with x squared, so we have the factors at x and x. And we have for factors negative 12 whose sum or difference, okay, will be at -1. So we're going to have more weight given to the subtraction than to the addition. So we're going to have the quantity of x plus 3 times that of x minus 4 equal to 0. And again, just applying what we have with the zero product property. Okay, so if we have x plus 3 equal to 0, okay, so we have that x is equal to -3. And if we have x minus 4 equal to 0, we're going to have the x is equal to 3. Make that x equal to 4. Okay. All right. So for what we have in the setup, okay, so if I form a table of intervals, okay, so you have with intervals, okay, so we have forming about the zeros of -3 and 4. Okay, so we have at the lower ends, we have those values of x which will be less than -3. And we're going to have, followed by those values of x, okay, greater than -3 and less than 4. And with 4 as the second and last exclusion, okay, we have those values of x, okay, which will be greater than 4. Okay, and just once again, setting up a table. Okay, so once again, we have the procedures, okay, to include selecting input values and then testing out what we have for the value of the function at each input. Okay, so again, we have f of x is equal to -x squared plus x plus 12. Again, we're looking at, after this, okay, we're looking at the sign of f of x. Okay, so just setting up the partitions among the rows and the columns. Okay, so we have concerning inserting the test values that we have for the inputs. Okay, so we have for the first, okay, we have referencing those values of x that will be less than -3. So a possible choice, okay, we go with -4. And then we have for the next subinterval, okay, we can select anything greater than -3 and less than 4, okay, and we can go with 0. And then for anything greater than 4, okay, we have 5 as a possible choice. Okay, and looking at what we have for the respective outputs. Okay, so with x at -4, okay, so we just have in the procedure. Okay, so you have the negative of what is going to be the square of -4. Then we have plus -4. Then we have followed by the addition of 12. Okay, so for what we have here, the square of -4 is 16, but we're still taking the opposite sign of this. Okay, so you have -16, and we have -4, which will be -20, and we have plus 12. So we're going to have for this particular output, okay, we're going to have, again, that's a plus 12. So you have -20 plus 12. Okay, so you're going to have -8. And in the case of what we have for f of 0, okay, so the variable terms will become negligible whenever x is set to 0, and we have plus 12. So f of 0 is equal to positive 12. And for what we have in the case of f of 5, okay, so we're looking at the negative of the square of 5 followed by the addition of 5, and once again we have plus 12. So we have 5 squared is 25, and the opposite sign of this we're going to have a -25. Okay, and we have, you can cluster together and say we have plus 17, but if we just do it gradually, you have -25 plus 5 is going to be at -20, and we have -20 plus 12. Okay, so again, that is going to be a bit of history to repeat from the first case where we have the sum or the collection to amount to -8. And so we have with the sign value of f of x, okay, so we had with the selective input value of -4, okay, as a sample of anything that is less than -3, we had the output to be a negative value. So any value of x you select that is going to be less than -3, okay, the output is always going to be negative for that particular function. Okay, so we have in the case of the sign of f of x, okay, so we're going to have to be a negative. Okay, so we have the f of x is less than 0, and then for anything greater than -3 and less than 4, okay, the output is going to be positive. So we're going to have the f of x is greater than 0, and then anything that we select, okay, greater than 4 for the input, okay, the output is going to be negative. Okay, so we're going to have the f of x is less than 0. Okay, so for what we have among the 5 parts in this problem, okay, so we have in part A, okay, so where we have -x squared plus x plus 12 is equal to 0. Okay, so we're going to have in the case of the solution, again, this is what we had at the initial stage. Okay, so we had x equal to -3 as well as x is equal to 4. And in terms of what we have with the inequalities, okay, so we have negative x squared plus x plus 12 is less than 0. Okay, so we have with this function at negative x squared plus x plus 12 is less than 0, we'll be looking at referencing where f of x is less than 0. Okay, so where f of x is less than 0, okay, this will apply to the first and the last subinterval portions. Okay, so we're looking at those values of x less than -3, along with those values of x that will be greater than 4. Okay, and we have in the case of the next part, okay, where we have less than or equal to 0. And I'll just copy this particular part since we have almost the same statement. Once again, okay. Okay, so again, this time we have less than or equal to 0. So we have f of x is less than or equal to 0. And again, direction-wise, it'll be the same as f of x is less than 0. So we're looking at applying the same limits, but we might be inclusive of the zeros involved, namely -3 and 4. So with the equal to 0 portion, okay, -3 and 4, okay, create the equal to 0 dynamic. So the difference this time between less than or equal to 0 and less than 0 is that -3 and 4 will be enclosed in the brackets. Now for what we have in the case of part D, so we have just changing directions. Okay, so this time we have negative x squared plus x plus 12, okay, is greater than 0. And so here we have the f of x is greater than 0. So if we look at what is in the chart, okay, where the function is going to be a positive output, so this will be in the middle case, whereupon we have applying for those values of x between but not including -3 and 4. Okay, and then we have for the remaining portion, okay, whereupon we have negative x squared plus x plus 12 is greater than or equal to 0. Again, this will be the same direction as where we have f of x is greater than 0, so we're involving, once again, the limits of -3 and 4. And since -3 and 4 create the equal portion relative to 0. So it's addressed in part E but never in part D. So -3 and 4, okay, remains in parentheses in part D, but with the equal portion addressed, okay, and since -3 and 4 set the function equal to 0, we're going to have -3 and 4 enclosed, once again, in brackets. All right, now for what we have for the next item, now we have comparison between variable terms in the inequality. And for what we have in the case of number 26, okay, we have that d squared is greater than or equal to 6d okay, now writing as comparison to 0 inequality case, so we're going to have d squared minus 6 times d is greater than or equal to 0. Okay, and so we're going to have for the function, okay, so we have f of d is equal to d squared minus 6 times d, and looking for the zeros. Okay, so again, if I had d squared is equal to 6 times d, and I wrote or expressed this quadratic equation in standard form, so I have d squared minus 6 times d is equal to 0, and looking at factoring, okay, so I have d times, okay, the quantity of d minus 6 is equal to 0, so I have d is equal to 0, and for d minus 6 is equal to 0, so I have that d is equal to 6. And so we're going to have for the zeros, okay, so we're going to have at 0 and 6. Okay, now setting things up, okay, again we have with our table of intervals, okay, so we have 0 and 6 for the zeros. Okay, so we have at the lower end, okay, we have those values of x less than 0, and then we have those values of x, or d rather, between 0 and 6, and then we'll have those values d that will be greater than 6. Okay, and so just with the change up in the variable, okay, so we got for the test value d, and again we have the function in d, so we have f of d is equal to d squared minus 6 times d, and once again we have the sign of f of d okay, so once again just dividing the column headings as well as the row headings. Okay, so we have first things first, okay, so for the test value d, okay, so for the first portion, okay, so we have anything that is less than 0, so that's going to be any negative value. Okay, so we might go with -1, and anything between 0 and 6 we can just go with the number 1, and anything greater than 6, okay, we can just go with the number 7. Okay. And so we have for testing each of these input values out, so we have with f of d equal to d squared minus 6 times d, so we have f of -1. Okay, so that's going to be equal to the square of -1 minus 6 times -1. Okay, -1 squared is 1. -6 times -1 is going to be a +6. And so we're going to have for the output, okay, that is going to be a +7. And for what we have in the case of f of 1, okay, so you have 1 squared minus 6 times 1. Okay, so you have 1 squared is 1, negative 6 times 1 is negative 6, and 1 minus 6, okay, this becomes negative 5. And for what we have in the case of f of 7, okay, so we have 7 squared minus 6 times 7. So 7 squared is 49, negative 6 times 7 is negative 42, and the difference comes out to plus 7. And for what we have in the case of the sign value of the function f of d, okay, so for any input that is negative, the output is going to be positive. So we have the f of d is greater than 0, and anything higher than 0 but less than 6 for the input, the output is going to be negative. So we have the f of d is less than 0, and then anything selected that is greater than 6, okay, for the input, the output is going to be positive. So we're going to have the f of d is greater than 0. Okay, so just taking what we have, going back to our original setup. Okay, so we had d squared is greater than or equal to 6 times d, and as a comparison to 0 inequality, we have that d squared minus 6 times d is greater than or equal to 0, and that is just signaling where we're going to have f of d is greater than or equal to 0. So in referencing what we have from the table, okay, so f of d is greater than or equal to 0. Okay, this will be in the same direction as where f of d is greater than 0. But again, you might have brackets around the zeros. Okay, so we're going to have, in the case of the solution, okay, so greater than or equal to 0 is in the same direction as greater than 0. So we're involving the limits negative infinity and 0, as well as 6 and infinity. And in terms of the enclosures, now again, infinities are boundless, so they stay in parentheses. And as for 0 and 6, again, those values created the function's capacity to be equal to 0. Okay, so with the equal to 0 part to be satisfied, okay, we're going to have 0 and 6 in the brackets. Okay, so that's going to be your interval solution for this particular inequality. All right, now in the case of number 29, okay, so we're going from the letter x to the variable d, and then finally to the letter m. Okay, so we have in this one, we have that m squared is less than 49. As a comparison to 0 inequality, okay, we have m squared minus 49 is less than 0, and okay, so we have in the case of the setup, okay, so we can say that we have f of m is less than 0. Okay, now, okay, so we're going to have right away that f of m is equal to m squared minus 49. Okay, so looking for the zeros. Okay, so if I had m squared equal to 49, and just writing as a quadratic in standard form, and you could also use the square root property of equality. So we have here, with the difference of squares, so we have the quantity of m plus 7 times that of m minus 7 is equal to 0. So we have m equal to negative 7 and also m equal to 7. If I set the respective factors, m plus 7 and m minus 7 equal to 0, so we have that f of m is equal to m squared minus 49. And as for the zeros, okay, again we have a negative and positive 7. Okay. All right, so in setting up a table of intervals, okay, so we have with negative 7 as the smaller 0. So we have those values of x, okay, less than negative 7. And then we have those values of m. I think I might have said letter x, but I meant the letter m. So you have between negative and positive 7. Then we have those values m, which would be greater than 7. Okay, so just initiating, okay, with the tested values for the inputs. Okay, so for the first, if I select anything less than negative 7, okay, so negative 8 is a possibility. And between negative and positive 7, again, I can select 0, and anything greater than 7, I'll just go with the number 8. And once again, we have with the function f of m, so I have m squared minus 49 and again, just testing each of the inputs out. Okay, so we have with m at 0, okay, right away 0 squared is 0 minus 49, so we have a negative 49. And for f of negative 8, okay, so we have negative 8 squared minus 49. Negative 8 squared is 64 minus 49, and the difference is going to be positive 15. And for f of 8, we're going to have the same final destination. Okay, or just like the square of negative 8, the square of 8 is 64. And take away 49, so we have that difference once again to be at 15. and with the sign of f of m. Okay, so anything selected that is less than -7 for the input. Again, the output is going to be positive, so we're going to have the f of m is greater than 0, and then anything greater than -7 and less than 7 for the input, the output is going to be negative. So we have the f of m is less than 0, and then finally anything selected for the input that is greater than 7, the output is going to be positive. Okay. Thought I had copied this, but apparently I did not. There we go. Okay, so we have m squared is less than 49. And again, as a comparison to 0 inequality, okay, that becomes f of m is less than 0. So looking at what we have in the table where f of m is less than 0, just referencing what we have at the very top, and that would be the interval section, whereupon we'll have those values m, whereupon -7 is less than m is less than 7. And so that is going to be our solution. Okay, so no brackets in this one due to the nature of the inequality itself. All right, now for what we have in the case of number 33, and now this inequality we have with the expression displayed in factored form. Okay. All right, so I have the quantity of x plus 4 times that of x minus 1. We have times quantity of x minus 3 is greater than or equal to 0. Okay, so we have, in this particular case, right, so I have already with the factored form, we have that f of x is greater than or equal to 0. Okay, so I have f of x, again, so I have x plus 4, quantity times that, or the quantity of x minus 1 times the quantity of x minus 3. Okay, and again, just looking at the zeros. So I have the quantity of x plus 4 times that of x minus 1 times the quantity of x minus 3 is equal to 0. Okay, so with x plus 4 equal to 0, okay, so we have x equal to -4. From x minus 1 equal to 0, I have the x is equal to 1. And for x minus 3 equal to 0, I have the x is equal to 3. Okay, so I got this function. And again, for the zeros. Okay, so I have -4, 1, and 3. Okay, and now since I have 3 distinct zeros, okay, so I'm going to end up with a wider table in comparison to what I have had worked with previously. Okay. All right, so we have with the zeros. Okay, so these happen to be in increasing order. Okay, so with -4 as the smallest of the zeros, so we have at the lower end, we have those values of x less than -4, And then we have those values of x greater than -4 and less than 1. And bypassing 1 just as -4 was bypassed, we have those values of x greater than 1 and less than 3. And with 3 being bypassed, we're going to have finally at the highest end, we're going to have those values of x greater than 3. And for what we have in the case of the table formation, okay, so I have the test value x. Again, I have the factored form of the function. And finally, we're looking at the sign of f of x. Okay, so for what we have among our tested values, okay, so anything selected less than -4, we can go with -5. And for values of x between -4 and 1, but not including -4 or 1, we can go with 0. And then we have between 1 and 3, well, if you select an integer, we can only use the number 2. And then anything greater than 3, okay, 4 is a possibility. Now for the value of the function, for each of these inputs, okay, so you have with -5 as the input, so you have -5 plus 4 is -1, -5 minus 1 is -6, -5 minus 3, okay, so that is going to be -8. Okay. So we have for the output, okay, this is going to be a -48. Okay, now with f of 0, okay, so I have 0 plus 4, so I have 4. Then I have 0 minus 1, so I have -1. Then I have 0 minus 3, so that would be -3. And so I got -4 times -3, so we're going to have a positive 12 for the output. For f of 2, 2 plus 4 is 6. 2 minus 1 is 1. 2 minus 3 is -1. So this output, okay, this will be at -6. And for what we have in the case of f of 4, okay, so you have 4 plus 4 is 8. And we have 4 minus 1 is 3. And 4 minus 3 is 1. And taking the product, so you have 8 times 3 times 1. So that's going to be a positive 24. Okay. And in the case of what we have for the sign of f of x, okay, so we have a negative, then a positive, a negative, and a positive. Okay, so as we proceed from one interval section to the next. Okay, so first we have f of x is less than 0. Then we have f of x is greater than 0. So it's like we're alternating between less than and greater than. Right. So just going back, okay, so we have with the problem, okay, whereupon we have with our function, okay, being greater than or equal to 0. Okay, so direction-wise, okay, we have along the same pathway as where we had the function to be greater than 0. So we're involving the same limits. The difference can be in the grouping symbols. Okay, so we have same direction, so we're involving -4 and 1. And we have f of x greater than 0, so we're involving 3 and infinity. Okay, and once again, infinities are boundless. Okay, so this infinity is going to be in the parentheses. Okay, and now for the -4, the 1, and the 3. Okay, the nature of the inequality is inclusive of equal to 0, and all of the amounts of -4, 1, and 3 will set the expression equal to 0. And so this means that -4, 1, and 3 will be bracketed. Okay, so this will be the interval solution for what we have for this particular inequality. Okay, so you have between and including -4 and 1, and also going from and including 3 on out to infinity. All right, now just making a reference to what we have regarding inequalities and also with polynomials and in behavior. I'm just going to sort of use building blocks here. Okay, instead of looking at determining the end behavior, of a polynomial function, and I'll have this one in factored form. Okay, so you have x squared times, okay, the quantity of x plus 2. We have times the quantity of x minus 3. Okay, now in kind of creating a dynamic here. Okay, so you got your function. You're looking at the end behavior. Okay, so there are two components here. Okay, one is going to be looking at the coefficient of the highest degree term as well as the degree of the function, which will be in the highest degree term. Okay, and so just looking at what we have for the highest degree term. Okay, so we have x squared for the first part, and then from x plus 2, you take the higher order part. Likewise with from x minus 3, I have x. So the highest degree term, you're looking at taking the product of x squared and x and x. So the highest degree term is going to be x to the fourth, okay? And again, since we're looking at coefficients, okay, so you're looking at like 1x to the fourth. Okay, and so we have for the leading coefficient a of n, again, so this is going to be 1. And so we have a positive value. And for n itself, okay, this is from the fourth degree of x, so n is equal to 4. Okay, so leading coefficient is positive, and the degree of the function is going to be even. And so for what we're going to have here, again, so we have a of n is positive, and we have that n is even. So for the end behavior, and just kind of referencing once again, if the degree is even, it's going to behave the same way at both ends, okay? And with the coefficient being positive, it's going to be up to the left and up to the right. Okay, now, and say that with, okay, so we got the end behavior. Okay, now let's say that just looking further into the details. Okay, so here we're looking at determine the zeros and their multiplicities. And where the graph crosses and touches the x-axis. Okay, so again, still working with the same function. Now the end behavior, again, you have up to the left and up to the right. Okay, now for the zeros and the multiplicities. Okay, so I'm just going to kind of do a little bit of color coding here. Okay, so you got x to the second, And we have with x plus 2 and x minus 3, we don't have any explicitly stated degrees, but then we have just the degree to be 1. Okay, so in the case of the zeros and multiplicities, and whether the graph is going to cross or touch the x-axis. Okay, so for what we have at the start, okay, so from x, we have x equal to 0. And if I set x plus 2 equal to 0, I'm going to have x equal to negative 2. And if x minus 3 is equal to 0, I'm going to have the x is equal to 3. And again, multiplicity being reference to the power to which the corresponding factor of that 0 is going to be raised. So we have 0 stems from x, which is raised to the second. And negative 2 stems from x plus 2, which is first order. And 3 stems from x minus 3, which is also raised to the first power. And again, if the multiplicity of the 0 is even, then it's going to touch. So it's going to touch at x is equal to 0. And with 1 and 1 is odd values, that means that at those respective zeros, the graph is going to cross the x-axis. Okay, so it's going to cross at x equal to negative 2. And it's also going to cross at x is equal to 3. Okay, so this is kind of what we have so far. Okay, now, and let's say that for what we have at the moment, okay, so this is what we have on the table so far. So with this function, you have in behavior, you have up to the left, up to the right, and again, you have the dynamics about the x-axis where you have touching at the origin and crossing at x equal to negative 2 and also at x equal to 3. To just kind of give you sort of an overview. Okay, so you have with our zeros, so you have 0 and negative 2 and positive 3. And again, we have the end behavior. You have up to the left and up to the right. Okay, so I'm just going to okay, so for the extreme ends, okay, so you have up to the left and up to the right. And again, in terms of the behavior, okay, about the x-axis, okay, so you have, again, you have cross at x equal to -2, touch at 0, and again to cross at x is equal to 3. So you have crossing from above to below. And it starts to rise again, so you have to touch at the origin. It's going to dip, okay, and then you have to rise back up. And once we get to x is equal to 3, the graph again is going to cross. So again, this is what we have for the graph of f of x is equal to x squared times the quantity of x plus 2 times the quantity of x minus 3. Okay, and just I think I'll copy this. So again, we have with f of x, okay, so you have equal to x squared times the quantity. Okay, so you have x plus 2 times the quantity of x minus 3 again, we have our zeros. Okay, so you have 0, -2, and 3. Now let's say if we were to set up an inequality table. Okay, so you have 0, -2, and 3. Now the smallest of the zeros, okay, we have at -2, so we have at the lowest ends, okay, we have those values of x less than -2. If we bypass 2, you have approaching 0. And bypassing 0, we have approaching 3. And then we have at the highest end, we have those values of x which will be greater than 3. And again, just separating. And for what we have regarding the tested values for the inputs. Okay, so we can select anything less than -2. Okay, so -3 will fit the bill. Anything between -2 and 0, where there's only one integer we can input, and that is going to be -1. And then between 0 and 3, we could put in either 1 or 2. We'll just go with 1. And anything greater than 3, we can just go with the number 4. Okay, so we're going back to our function. Okay, so we have x squared times the quantity of x plus 2 times that of x minus 3. Okay, so we have with -3. Okay, what's going to happen here? -3 squared is 9. -3 plus 2 is -1. -3 minus 3 is -6. So we got 9 times -1. Okay, that's going to be -9 times -6. So f of -3. Okay, so that's going to be a positive 54. Okay, now for f of -1. Okay, so I have -1 squared times -1 plus 2 times -1 minus 3. So -1 squared is 1. -1 plus 2 is 1. -1 minus 3 is -4. Okay, so you have this output is at -4. And for f of 1, so you have 1 squared times quantity 1 plus 2 times that of 1 minus 3. So you got 1 squared is 1. 1 plus 2 is 3. 1 minus 3 is -2. And this output, okay, we have at -6. And for f of 4, so you got 4 squared times 4 plus 2 times 4 minus 3. So 4 squared is 16. And 4 plus 2 is 6. 4 minus 3 is 1. And 16 times 6 times 1. So that will be a positive 96. And for what we have in the case of the sine of f of x, okay, so anything we plug in less than -2 for the input, the output is going to be positive. So you have the f of x is greater than 0. Anything between -2 and 0 is going to be a negative output. Okay, so we have that f of x is less than 0. Likewise, anything greater than 0 and less than 3, you're going to have a negative output. And anything greater than 3 for the input, the output is going to be positive. And just sort of compositing together. Okay, so for x squared times the quantity of x plus 2 times that of x minus 3. Again, if I have equal to 0, well, again, you're going to have, for the solution, again, you're going to have x equal to 0, -2, as well as 3. And if I have x squared times the quantity of x plus 2 times that of x minus 3 to be less than 0, so this will be situating whereupon f of x is less than 0. So where f of x is less than 0, okay, so you have with these interval sections. Okay, so I'm looking at over here. So I have values of x between -2 and 0. And then I have also between 0 and 3. So I have parentheses throughout. Now, this is where the trick part could come in. And I'm throwing this in also because there might be an Alex item that might throw in this little bit of a loop. If I have x squared times the quantity of x plus 2 times that of x minus 3 to be less than or equal to 0, and we have whereupon f of x is less than or equal to 0. Okay, so where f of x is less than or equal to 0. So I'm looking at applying the same limits. And guess what? Okay, the negative 2, 0, and 3 create the equal to 0 parts. But guess what? Since 0 is now included, this means that this union here, okay, since 0 is included, we're going to have the intervals to become 1. So this means that for that particular solution, we're going to have just continuity between and including negative 2 and 3, since those two interval sections were joined together. Okay. And as for the rest, okay, where I have going the other way, where I have x squared times the quantity of x plus 2 times that of x minus 3 is greater than 0. Okay, so I have greater than 0 with the first and the last interval sections. Okay, so again, no equal sign, so I had the exclusive use of parentheses. And where I have x squared times the quantity of x plus 2 times that of x minus 3 is greater than or equal to 0. Okay, so again, negative 2 and 3 will set the function equal to 0. And using the grouping symbols, again, infinities are boundless. So here I maintain the use of parentheses, and again, negative 2 and 3 set the function equal to 0. So negative 2 is going to be in bracketed. 3 likewise, okay, and there were no consecutive intervals that could be linked together, as was the case with negative 2 to 0 as well as 0 to 3. And since 0 was the tie that managed to bind, okay, that we were able to unite these separate sections into one. Okay, so the less than or equal to 0 part, okay, was kind of unique among these 4 inequality statements. And just kind of taking what we have as a little bit of an overview. Let's see if I can get this in. Okay, so with the graph from earlier, okay, so working with the same function in behavior, have up to the left and up to the right. And again, we have cross, touch, and cross at the x-axis for the respective zeros. X equal to -2, x equal to 0, and x equal to 3. And just kind of show you, okay, where these numbers came in. Okay, now again, f of x is just another way of saying what we have for y. So I have, like, when x is -3, the corresponding value was at 54. So you have, like, if I were to add any details, you have like -354 would be a point. And say between -2 and 0, I had like -1, -4. And we have, again, so we have the origin, and between 0 and 3, so I have like 1, -6. I'm not drawing this according to scale, but you have like -3, 54 is a point, -1, -4 is a point, 1, -6 is a point, and then we have, and then we got 4, 96. So it's just going to be, again, I'm not drawing this according to scale. Okay, so like 496, 1, -6, -1, -4, and -354 will be among the 4 points, and it does lock in consistently with where we have crossing and touching the x-axis for the corresponding zeros, as well as the dynamics that play out in terms of the end behavior of the graph of this function. Okay, and now let me just mention something here, and I'm not going to get so much into the granular details, but along with polynomial inequalities, we're going to have rational inequalities. And let's say that if we have so you have for rational inequalities. Okay, and let's say that if I have now r of x, okay, is equal to x plus 4 all over x minus 3. Okay, and what I'm going to do here is that I got two x expressions, okay, and for what I'm going to have here, so we have with the zeros. Okay. Okay, so if I have like x plus 4 equal to 0, so I have x equal to 4. Now this one, make that x equal to -4. This one is in the domain because this comes from the numerator, x plus 4. And you can have a 0 numerator as long as you do not have a 0 denominator. And for the other 0, we have x equal to 3. And this one is not in the domain. Okay, and if we just set up tables around these zeros, okay, so between -infinity and -4, and then we have between -4 and 3. And we have those values of x that will be greater than 3. And I'm not going to structurally complete the table, but I just want to, for the tested values that we have for x. Okay, so anything less than -4, we can go with -5. Anything between -4 and 3, we can go with 0. Anything greater than 3, we'll go with 4. And for the function r of x is equal to x plus 4 all over x minus 3. So we have r of -5, we have r of -5, r of 0, and r of 4. And just stressing the sign values. Okay, so r of -5, this will become positive 1/8. R of 0 becomes -4/3. And for r of 4, okay, that's going to come out to a positive 8. And for the sign of r of x, okay, so this is going to be positive. So r of x is greater than 0. Then we have next, you have r of x is less than 0. And then we have positive. For the last, you have r of x is greater than 0. And then for the inequality scenarios, okay, if I have that x plus 4 is less than 0, this will apply to the middle section. So between -4 and 3. If x plus 4 is less than or equal to 0. Okay, now again, -4 is in the domain, 3 is not. So -4 is going to be in the bracket. However, 3 is going to stay in the parenthesis since this value is not in the domain. And then we have for x plus 4 is greater than 0. Okay, so we have with the first and last sections, okay, so you have between -infinity and -4. And you have between 3 and infinity. So you have parentheses throughout, and then for greater than or equal to 0. Again, -4 is in the domain, so that is going to be in the bracket. And again, the 3 is going to remain in the parenthesis since 3 is not in the domain. So if you got your equal signs, you're going to put brackets around only those zeros that are in the domain. In this case, -4 is the only 0 in the domain. So this is how all of this is going to play out.